Hello, folks. Welcome back. Today, we are going to be doing some examples, more arrays. We have seen arrays and also vectors. I'm going to go back to arrays, and now we're going to be doing some searches and some basic sorting. Um, the first thing we need to do is work on a linear search. Um, Linear search is how we search for something. Um, and I'm going to, through the magic of copy paste, search an array in C++, include IOStream using namespace std. I'm gonna make a constant and it's 10. That's only because 10 is the number of records. Okay, I'm gonna have 10 records on my array. And this is a linear search. So I'm gonna have a function that returns an int. It receives as a parameter, here's my array of ints. And then I got two ints. I'm obviously just declaring my linear search. I'll go over it right now and down to the linear search. Here's my array. I receive it as a parameter, int n and int x, right? So n is the number of items in my array, the number of items in my array, and then int x is what I'm looking for, right? I'm looking for x. So how linear search works, you basically go line by line. That's what's called linear. You know, here I start with index equals 0, position equals -1. And the reason I'm using -1 is because if I don't find my my number I'm searching for, I have to return something. And the easiest is to return a -1, meaning I didn't find the number. And I'm going to have a flag starting with false right off the back. When I start my search, I have not found my records. It's starting. Now, this is the main context of the search. While index, which is in 0, is less than n, which is the number of items. In other words, I'm going to search for the number of items, and is not found. As long as it's not found, it's going to continue to do this. I'm basically going to I'm going to check with an if statement if my array of index equals x. Remember, double equal sign equals x. If it finds it, obviously I do found equals true, so that kicks it out of the while loop. And the position is whatever index is worth. If it doesn't find it, it continues an increment index, and eventually, if I don't find it, it'll loop out because of this statement right here. The moment is equal to n or above, it's obviously going to get out. And then I'm returning the position. Again, if it finds it, I return index. If it doesn't, it returns -1. I have my array with a maximum amount of 10 items. And then I just put them in, any order, 3, 7, 1, 8. I'm putting the numbers 1 through 10, but in different orders, right? Then I have 4 variables, a equals 6, and b equals 12. Then I lowercase a and b. Remember, in C++, lowercase a is different than uppercase a, right? It's different. So these are actually 4 different variables. And then I'm saying, look, a and b are going to be my positions, okay? I'm just doing 2 examples where one is going to be found and the other one is not. And I'm saying, look, for a, lowercase a, do the search of the array, maximum of 10 items with a value of 6. And then for B is going to be the same, but with a value of 12. If you look at the array, 6 is here, but 12 is not. And then I'm just going to display my result. If A equals -1, it means it wasn't found. Otherwise, print out my record number. And I'm going to do the same for B. Because I have 2 searches, I'm going to print out one should be true and the other one's false. And so that's my program. I'm going to go ahead and run it. And here it is. The record position is 9, and the second one was not found. This one is not found. This one is 9. Now remember, I have 10 items, but they start with 0, as you can see right here, 0, 1, 2, 3, and 9 is the position of the number 6. So the position is 9, and then the other one, record not found. So that is a linear search. The advantages of the linear search is that it's very easy to implement. Obviously, I'm just going record by record until I find it. And if I don't, I return -1. I mean, this is about as easy as it can get. So there's just one problem. Here I only have 10 items. This is going to be very fast on my little a computer with only 10 records on it. What if I had a million records or 10 million records? Well, this becomes a little bit of a problem because now I'm searching for something a million times. So yeah, that's the only drawback to linear search is very slow, very fast. I mean, for short numbers, but very slow for big numbers, and obviously uh, not too effective. Um, so that brings us to uh, the binary search. And I'm going to do searching arrays in C++. And again, I still have my 10. Here's my array search, int, int, int. Everything's the same. But there's only one problem with binary searches. And whereas it's, I see it as a problem. The main problem is it has to be sorted. It has to be, look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If it's not sorted, it doesn't work. Now, before I continue with the main part of the program, let's go to the search and see why is that. So I have several variables. This one's a little bit harder to understand because I got more variables and all that, but don't worry about it. Here's my array. Here's the number of items, and here is X. My first position is 0. The last position is n minus 1, the number of items minus 1. Remember, if I have 10 items, 9 is the last number because I start with 0. So that's why last equals n minus. Then we have a middle, which I don't know what position is. And then again, my position is -1. If I don't find it, this is what's I'm going to be returned. And of course, it starts with a false. So here's my loop. While not found, obviously, while not found, and first less than equal to last. So while this one is less than this one and it's not found, I'm going to do my loop. Now let's go inside the loop. Let's analyze this. And here's how it works. Before I explain this program, you remember ever playing that game where someone says guess a name between 1 and 10 and you say 5, and then they say no, it's higher, so you go 7, and they say lower and you're like, oh, it was 6. That's exactly how this works. It works by guessing the middle number. If it's the number, it returns that. If it doesn't, then what it does, it says, oh, what is it, higher or lower? Let's say it's higher, then it goes to the middle number of the higher part of the array. And so it keeps breaking it in half and half and half and half, just like the game. So the middle is my first plus last divided by 2. That gives me the middle number. If I find it right here, my position is the middle number, and it is found. Otherwise, if it's greater than the x, see how if it's greater than x, then it's between middle minus 1, and then otherwise it's middle plus 1. So I'm going above and or below depending on what until I find it. Now this works very good. I'm going to run it right here, and I have my searches right here. A6B12. The record was number 5. For the number 6, because I changed it. He's number 6 is position number 5, and there it is right here. And the other one was not found because I'm above the range. Now, this works faster than the linear search because I'm cutting in half, then in half, then in half, and so on. When it's only 10 records, you can't tell the difference. You have 100 records, maybe not. 1,000, you will start seeing the difference in times. You will really tell the difference in time, especially when it's 10,000 or 100,000 records. But there's one problem. It has to be sorted up front. This only works. Imagine if I had 6, 3, 9, and I'm splitting it in half. Well, I'm never going to find my number. I may find it by chance, but yeah, it's if I have them they're not in order, and my middle number is 6, and I'm saying no, what I'm looking for is a 7, and it goes up, but the number 7 was in the first position, I'll never find it. It's just gonna say nope, it's not there, and even if it is there, it's just gonna say no, I couldn't find it. It's not gonna give me an error. It's just not gonna work. So that's how these are the two most common searches are. A linear search or a this binary search. But this brings me to the next topic of this article that I'm talking about, this tutorial, sorting. So I'm going to cover three basic sorts. Let's go ahead and do the first one. And it's called a bubble sort. And through the magic of copy paste, here is my bubble sort. I'm going to call this bubble sort. And I'm going to have actually two variations of bubble sort, but this is the first one. It's one of the most simple sorts out there. Look at the array. Again, this is all the same. Here's my void. Bubble sort will not return a value. It's just going to sort the array. I send in an array, and I have a variable right here, which is going to be the number of items. And so, yeah, this actually could be optional because I have a constant here, but we'll worry about that later. So here it is. My array starts with 3, 7, 1, 8, 4, 10, 5, 9, 2, and 6. And what I've done here is basically a little for loop. That's all it is. I'm saying for I equals 0, I all the way to 9, because 9 is less than 10, I plus plus, C out an array of I, and the slash T. This here, all it's going to do is print out these numbers. That's all it's going to do. Then I'm going to sort it. Then I'm going to print them again. That's the entire program. Now, let's go to the bubble sort. Before I run the program, I receive an array, and I receive the number of items. Now, I've chose to send n as the number of items, but remember, my number of items is a constant right here. I could ignore this right here, and I don't have to worry about it, but I'm gonna do it only because normally we do. So here's how this bubble sort works. I have a swap, which is Boolean, and then I have an integer, which is temp, and then I do swap equals false. That's the initial value. And then I say for int I equals 0, I less than n minus 1, I plus plus, on the entire range of items in my array. If 1 is bigger than the one that's next, I swap it. And I do a swap equals true. And when I swap them, it continues to go, right? Every single time that loops, I'm going to start with a false, and I'm going to do a swap if it's true until it's no longer true. So let's see this in action. And this is how it works. The original 3, 7, 1, 8, 4, 10, 5, 9, 2, and 6, and then sorted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I sorted it out. Now, why would I do this? Well, for one, once I've sorted it, I can now do binary search, which is much faster. Again, if it's a million records, a binary search is going to save me a lot of time. What I need to do is really concentrate on how I'm going to sort them. Bubble sort is very effective, easy to implement, but it does have some drawbacks. It's one of the slowest sorts out there. So it is one of these slowest sorts out there. Now I'm going to do something here. And this is also a bubble sort. It is the same. Everything here is the same. I'm doing the bubble sort, which is void. Everything's identical. The only thing I've changed is the bubble sort itself. It's another variation of the same sort. And I call it a variation because they're called bubble sorts, but they do the same thing and they work the same way. This one is more common, however. While for I equals 0 until it's less than n, I plus plus, and then I do the second. And all I'm doing is comparing I to j. Now, remember on the other sort, I was comparing I to I plus 1 or j to j plus 1. I was comparing one element against the next element. Here, I'm saying, look, instead of dealing with that, right off the back, I'm going to say you start automatically with I. Whatever I value is, I'm going to start right there, and I'm going to increment j, and I'm just going to swap them if one is bigger than the other. It's a much easier to understand. And here it is. See, it's going to work just like the other one. It's going to sort properly. Again, the differences on the other one, I have a swap, and then it all boils down to this here. I have my first, and then I have the second, where the second is always ahead of the first. And then I swap them if it's required. On the other bubble sort, which is the same thing, identical. The only thing is on the other one, I'm only using one for loop or one, I'm actually doing a do while loop. So, but it's the same thing, okay? Don't get confused. It is automatically the same thing. Bubble sorts are great, but they're not the most effective. This is a linear, let me spell this right, and then sort. Okay. Same so far. Selection, sort, and my count to 10, my sum array. I'm doing the same thing. I'm doing my selection, sort, and I'm printing them out the first and afterwards. Let me run this, and then I'll explain the sorting procedure. So here it is, 1 through 10 on the bottom, all random in the top, because that's how the way I have them here. So let's talk about the sort itself. Now, this sort is called a selection sort. And the difference between a selection sort and a bubble sort is that this one is way more effective. It is also harder to explain. I mean, there is an algorithm, obviously, for both of the sorts, and I can only tell you, trust me on this, this one's a much better way. So we have a start, a middle, and a minimum value. There's a minimum index, and there's a minimum value. And here's my for loop. For the start equals 0, start less than n minus 1, and start plus plus. So in other words, I'm starting from the first element to the 9th element, actually to the 8th element, right? It's got to be less than 9, so it's to the 8th element. Start is, think of start as I, right? Start is I. So it could be I. Don't get too confused. My minimum index is start, which is this value right here. My minimum value is the array with that value. And then I have my second loop right here. And I increase by, I'm comparing for int equals start plus 1. In other words, I'm going to the next value up. And then I'm comparing. If I need to swap them, I swap them right here. And then I increment my arrays. I do this is a swap for here, believe it or not. I'm actually swapping the values. If they need to be swapped, I'm swapping them. If not, they stay by the way they are. It's very, well, it's more effective than the bubble sort. Let's put it that way. There are better sorting techniques out there. But yeah, this is the selection sort. And I'm going to run it again here, and there it is. Very fast. The difference in speed, and I've done it on a prior tutorial comparison on several, like at the quick sort and the bubble sort. And I don't think I included selection sort for that video, but in the future I'm going to do one with several sorting million records and see the times. I've done prior videos where I'm comparing Pascal to Quick Basic to C++, GW Basic, and I'm comparing bubble sort to quick sort. I believe I've done that. But in the future, once I'm done with these tutorials, I'm going to be doing some videos on C++ before I jump into probably Pascal or Basic. I'm not sure which one of the two I'll do. And when I do that, I'll be doing a specific video for sorting with like 5 or whatever sorting algorithms that I can recall, probably more. And then you can see the difference. Once we have, like, 100,000 records, you will be able to tell the difference. At this point, I don't want to do that because I haven't talked about many things like pointers and times, and I don't know, some things that I want to include in my tutorials before I jump into more heavyweight things. But in this sort right here, if you want to get something out of the tutorial, this is a great sorting. You can always copy it into your code and implement it. It's very, very effective. So now let's do through the magic of copy paste. Here we go. Now this, as you can see, is a much brighter. This is an actual application here. I'm including string. So this is a little bit different because I'm doing an actual thing here. I'm including string right here. Now, there is a table. There is a table that has multiple records, has 10 records. I invite you to, well, actually at the end of this video, I'll probably incorporate that table. In that table, I have 10 records. They have a item number, a description, the quantity on hand, and the cost. And what I've done, obviously I did it in Excel just for examples, and let me see if I can, I don't know if this will show on the video right there. If it is, I'll leave it. But here it is, items 1000 through 1009, the descriptions, the quantity, and the cost. This is sorted. I did this in Excel, just it's sorted. But here on my program, it's not sorted. I started with 1, 5, 7, 8. I did it unsorted. And I have multiple arrays. Now I have my sort array and I have my search array. And in my sort array, it includes 4 arrays as parameters, as my function. It's a function with a void, right? It's a void function, because I have 4 arrays that I want to sort. And my searching array is right there. So I start with an item, position, again, if equals true, and string of str. This Boolean here is because here's what the program does. I display all the items, then I sort them out, I display them again, and then I'll ask you for a item number, and I should, if I find the item, I should be able to tell you what the item is. Normally you wouldn't do this, but I'm doing this so you can see something. So here's the original array items. I'm just printing them out, that's all. And then I'm sorting them out, and then I'm printing them out again. That's all it does so far. Printing them, sorting them, printing them. And I'll go over the functions at the bottom. Then I'm saying, look, enter an item number. I enter into item, and I search for my item. If it's -1, that means it wasn't found. Otherwise, I print up all the item descriptions. It doesn't do anything fancy. And then I ask for another one, yes or no, send into string. If it equals n or n, and I don't know if you're using lowercase or uppercase. Again, it's false, and do while it is again. So while this loop will continue while again is true unless it's false. And if it's anything else other than n or n, it will be false. Okay, now let's go through the sorting. Here's my sorting. I got all my arrays, and here is my bubble sort. I'm using a bubble sort right here. Swap equals false. It's the same thing as the other sort that I showed you. Don't get confused. The only thing is here, I'm doing it for 4 arrays at the same time, because every single array has the value and it's the same identical position. Now, I could do this on a multi-dimensional array. I just haven't covered multi-dimensional arrays, so I didn't want to confuse you guys. That you can do this with a one multi-dimensional array. The problem with that is that multi-dimensional arrays, they have to be of the same type. And I do have strings and doubles and integers, right? Quantity and item number integers. My cost is double or float, it could be either one. And then my description is a string straight out. So I decided to do with the arrays instead. Since it's only 10 items, bubble array will do fine. Then I'm searching the array. Every time I search it, I go in linear way and then locate it. All right, so let's see how this works. And I'm gonna make this bigger right here so you can see it. And look, I'm displaying my items in random number like they are in my table. Here they are sorted 1 through 0 through 1009. It's the same. Now I'm asking for a number. If I put 1002, it's saying, oh, 1002 is a basic book. I got 6 of them and they cost $5.99. So basic book, I got 6 of them and $5.99. See? Do I want another one? Let's say yes. I can do 1006. And there it is, the description. Now let's say I put n, remember? N will throw it out. And boom, exit with code 0. So there it is. It works like I planned it to be. I got my arrays. I sorted them out. And I searched them. And if I'm successful, I print out the item number. It's a little example of how to use arrays. During this video, I pasted the table in front of the screen. If it doesn't show up, I'll add it at the end of the video. Sorry about that. I'm still not very good at this video editing thing. Thank you for watching this tutorial, and I'll see you in about a week or so. If you like it, you know what to do. Please like and subscribe. Thank you very much.